So far what we've been working on is the calculations with the mole, and now we're going to actually apply them to chemical reactions. So stoichiometry is just a fancy way to say you're doing these math calculations, but now we're going to involve actual chemical reactions. So it's the calculations of quantities of substances involved in chemical reactions. The big idea here is that the coefficients, and just to review, the coefficients are those big numbers in front of a chemical. The coefficients in a balanced reactions will show you the mole-to-mole ratio. It's the ratio of 1 mole of something to, or any moles of something to moles of something else. So for example, if we have N2 plus H2 yields NH3, the coefficients in front of them, the 1, the 3, and the 2, shows you that there's a 1 to 3 to 2 mole ratio, which means you have 1 mole of N2 for every 3 moles of H2, or you have 2 moles of NH3 for every 3 moles of H2. Keep in mind that when you add up the mass of something, like if I said the grams per mole from the periodic table for H2, you would not multiply it by 3. So don't include the yellow numbers when you're adding up the mass of something. So here's what this means. If you have this reaction, and let's say that I give you 6 moles of A, from this amount you can actually calculate the moles of B, the moles of C, and the moles of D. You can go to any other thing in the reaction. So you can calculate the moles of B needed to react completely. You can also calculate the moles of product C formed and the moles of product D formed. Let's do some examples and it'll make more sense. So if it says you have 2 moles of N2, just like we did before, you're going to start with what's given in the top left corner. Now, from now on, it's really important that you have 3 things. You have your number, you have the unit, and you have the chemical. You need all 3 of those things from now on. And I know it's tedious to write all that, especially if you have a big chemical, but if you do that, it'll definitely make your life easier. Then what you're going to do is take this unit, not the 2, but just the unit moles of N2, and pull it down diagonal. And what you're going to put on top is the moles of what you're looking for. So in this case, NH3. This is called the mole-to-mole ratio. So what we're going to do is switch over from information about N2 to information about NH3. These numbers right here are going to come from the coefficients from your balanced reaction. So if you find N2, there's no number there, which means it's a 1. If you find NH3, you have a 2 as a coefficient. So these 2 numbers are the coefficients from your reaction. And this will allow you to switch from N2 to NH3. So moles of N2 cancels, and when you calculate this, you get moles of NH3. So what this means is if you start with 2 moles of this, the N2, you can produce 4 moles of NH3. Let's try another one. Let's say that you want to produce 5 moles of NH3. We need to know how many moles of H2 should we start with so that we end up with 5 moles of product. So start with what you're given, 5 moles. It doesn't say what the product is, but there's only one product, so I know it's NH3. Then you're going to take this unit, the moles of NH3, and bring it down diagonal because you want to cancel it. On top is moles of what you want information about, so in this case the H2. Always set your units up first before you plug in numbers. These 2 numbers are going to come from your balanced reaction. So if you find NH3, there's a 2. And if you find H2, it has a 3 in front of it. So plug in your numbers from the coefficients from the reaction. And then you just have to do the math. Try this one by yourself. Pause the video for a minute and see if you can get this one right by yourself, and then check your answer. So if you start with what you're given, 8 moles of H2, bring the moles of H2 down. This time you're turning it into moles of nitrogen, and then these 2 numbers came from your coefficients. And this is the major idea for today. So this is really important. Notice all the stars. The only way to convert from one chemical to something totally different in the reaction is to use that mole-to-mole ratio that you can find from the coefficients. So if I give you information about one chemical and I ask you information about something totally different, the only relationship is that mole-to-mole ratio. So you have to have a balanced reaction with coefficients. If you don't have moles, the first thing is you need to get it into moles. So let's say that I give you grams, you can't use that mole to mole ratio until you're in moles. So the first step would be to get it into moles. So just to review, there's 3 things we can turn the mole into. We can turn it into liters, particles, and molar mass. So go ahead and pause the video and take a few minutes to draw this picture or write it down in your notes, and then I'll talk about it. But I want you to write it down first. So pause the video for a few minutes and go ahead and jot all this down. Once you have this written down, what I want you to notice is that if you cut it in half, this side is a mirror image of this side. The only difference is that everything on the left is for A, everything on the right is for B. So what we're going to do is connect from A to B, and notice the only connection is this one line right here, the mole to mole ratio, and you get that from the coefficients. So what you're going to do is use the coefficients to switch from the A side to the B side. But I might not give you moles, I might give you grams. Let's say I gave you grams of A, and I asked you for grams of B. So the first thing is you have to get it to moles of A. Then you can use the mole to mole ratio to get it to moles of B. Then you can go back to grams. So each side of the picture is what we've been doing for weeks now. This is the only new thing. This one connection here is the only new thing that we learned. Let's do one. It says how many grams of hydrogen gas are required for 3.75 grams of nitrogen to react completely. So just like before, we're going to start with what we're given, 3.75 grams. Since we need to switch from nitrogen to hydrogen, the only way to switch from one chemical to another is to use the mole to mole ratio. But I can't use that if I have grams. So the first thing is I need to get it to moles. Once I have moles of N2, I can use the mole to mole ratio to switch it to moles of H2. But I didn't ask you for moles of H2, I asked you for grams, so we'll have one more step. So we're going to go grams of N2 to moles of N2, moles of N2 to moles of H2, and then back to grams. So notice the only link between the two is the mole to mole ratio. So just like before, start with what you're given in the top left corner and make sure you have all 3 things, the number, the unit, and the chemical. We're going to take grams down diagonal. And the only thing you know how to turn grams into is moles using the periodic table. So on the periodic table, nitrogen's mass is about 14 grams per mole, but multiply it by 2, so you get 28. So this came from the periodic table. And anytime you use the periodic table, you'll have grams on one side, the other side you'll have 1 mole. So now grams cancels, and we're left with moles of N2. So now we're ready to use the mole to mole ratio that I just showed you. So you're going to take moles of N2, pull it down diagonal to cancel it, and on top is moles of the chemical you want information about. So in this case it's going to be hydrogen. Once you get your units set up, look in your reaction for these 2 numbers. So the 1 and the 3 came from the coefficients, 3 for H2 and 1 for N2. If they asked us for moles of H2, we'd be finished now. But they didn't. They said how many grams. So we need to do one more step. We're going to take the moles of H2 and pull it down diagonal and use the periodic table to turn it to grams. So the number on the periodic table for hydrogen is 1 gram per mole, but we have 2 of them, so that's why I multiplied it by 2 to get this. So this 2 right here came from the periodic table. And then you just have to calculate it. And you should get about 0.8 grams of hydrogen. So again, the only new step in this whole thing is this one step right here. This is the switch over that I just showed you. That's the new step. This one is very similar. You're given 5 grams of NH3. I want to know grams of H2. It's very similar, but I want you to try it yourself. So here's the process. We have to go grams to moles, then we can switch over moles to moles, and then back to grams. But I want you to pause the video and try it by yourself first, and then check your answers. So what we did is we started with what we were given, used the periodic table to convert from grams to moles, so the 17 came from the periodic table. Once you have moles of NH3, pull it down diagonal, and put moles of what you're looking for on top. These 2 numbers are the coefficients from the balanced reaction, and this is the only spot you'll ever use these numbers. Once you have moles of H2, we just need to get it back into grams. So pull your moles down, and you can turn it into grams. Let's do a few more of these. The next one is similar, but notice what the question is asking for this time. They didn't ask us for grams, they asked us for liters. So it's going to be just a little bit different. We're going to start with grams again, convert it to moles, go to moles of CO2, but this time at the end, instead of going back to grams, we're going to turn it into liters. So just like before, start with what you're given in the top left corner. Bring that unit down, and anytime you see grams, you need to think periodic table. So use the periodic table to add up C2H4, and you should get about 28. Once you've converted it into moles, you're ready to use the mole-to-mole ratio. So bring this unit down, it's the moles of C2H4, and we're converting it to CO2. These two numbers, the 1 and the 2, came from the coefficients. So notice there's a 1 in front of the C2H4, and there's a 2 in front of the CO2. And now this last step is a little different because they asked us for liters. So instead of adding up the periodic table CO2, you're just going to use 22.4. And then you just have to do the math. This one is very similar to the last one, so I want you to pause the video and see if you can set it up yourself. Start with 6.8 grams of water, and I want you to see how many liters of oxygen, the O2, would you need at the end. So go ahead and start with 6.8 grams of H2O and turn it into liters of O2. See if you can set up your fence and calculate it. But pause the video first so you can see how you do. And then check your answers. So you started with 6.8 grams, use the periodic table to get it to moles. That's where the 18 came from. Then we're going to use the mole-to-mole ratio to switch it over to oxygen. So the 3 and the 2 came from the balanced reaction. Once you have oxygen, you're going to turn it back into liters, or actually turn it into liters. We didn't start with liters, using 22.4. And then you just have to do the math. So we've done grams to grams, and now we've done grams to liters. The last one we're going to do liters to liters, and it's just the same thing. So if I give you 8 liters of hydrogen, and I ask you for liters of ammonia, we're going to go liters to moles, then moles to moles, and then back to liters. So start with what you're given. And this time, since we were given liters, we don't need to use the periodic table for that. So just use 22.4 to convert it into moles of H2. Once you have moles of H2, you're ready to use the mole-to-mole ratio to switch it over to ammonia. So these numbers came from the balanced reaction. Once you have ammonia, or moles of ammonia, you can turn it back into liters using 22.4. And there is one little shortcut that you may notice that if you have 22.4 on the bottom and 22.4 on the top, those two are going to cancel out. So really the only math you have to do is 8 times 2 divided by 3. But you can still type it all in if you want. And the last one I want you to try by yourself first. So it's very similar. It's again liters to liters. See if you can pause the video and set up yourself and calculate it, and then check your answer. So for this one, you use 22.4 to get it to moles of ammonia, use the mole-to-mole ratio to get it to moles of N2, and then use 22.4 to get it back to liters. So you should end up with about 7.5. There are 2 worksheets at the very end of your worksheet packet that are labeled Stoichiometry, and I want you to try a few of those to make sure that you understand how to do it. The answers should all be on the worksheets. That is all.